So in this video, I'm going to go over some examples of simplifying exponents and then discuss some more from section 1.3 using scientific notation and some geometric formulas. So these are the 5 problems that I'm going to show you how to simplify right now. If you haven't already, maybe pause the video and see if you know how to simplify these, and then compare your answers to mine. Okay. So I will go to my whiteboard and work through these problems. All right, our first problem is going to be 9x raised to the 0 power. Sorry, 9x to the 4th, all raised to the 0 power. Basically, since this whole thing is raised to the 0 power, it means that it equals 1. The whole thing equals 1. Our second example is going to be 2 to the 3rd over 2 to the 4th. Okay. And if we want, we can just use the definition of exponents to really understand how to simplify this fraction. That's the definition of exponents right there. And we can cancel common factors in the top and bottom. And we are left with 1/2. Alternatively, though, we could say that we can use our quotient rule, which is going to say we've got 2 to the 3rd minus 4. And that's going to be 2 to the -1. And the definition of negative exponents is it's actually division. So we are dividing by 2 once, which is the same thing as multiplying by 1/2. So just to recap, the answer to number 1 was 1. The answer to number 2 was 1/2. Now, problem 3, we've got 3x squared over y to the 3rd, and all of that is being squared. Okay. Well, first of all, we can distribute that power of 2 inside of the parentheses. Okay. So we've got our 3x squared being raised to the power of 2, and we've got our y to the 3rd being raised to the power of 2. Okay. Or sorry, that's distributing across the division. And now we'll distribute inside the parentheses. So our 3 is being raised to the power of 2, and our x squared is also being raised to the power of 2. And then in the denominator, our y to the 3rd is being raised to the power of 2. So we can simplify that to say that is y to the 3 times 2. All right. So in the denominator, we've got y to the 6th. And in the numerator, we've got 3 squared, which is 9, and x raised to the power of 2, raised to the power of 2 again, is going to be x to the 4. Right. So that is number C, letter C, number 3, simplified. Okay. Let's take a look at problem D. Here we have 14x to the -3 times y squared over 2x to the -3 times y to the -2. All right. So here we are going to have to translate what our negative exponents mean. So when we are multiplying by something to a negative power, it really means we should be dividing by it, and vice versa. So these negative exponents need to switch where they are. But in this case, since we have an x and -3 on the top and the bottom, we can just cancel those out. So we can also cancel out our 14 divided by 2 is going to simplify to a 7. Our x to the negative 3s are going to cancel out. And then we've got a y squared in the top and a y to the negative 2 in the bottom. Well, this y to the negative 2 can come up to the top and be a y to the positive 2. And since we've got y squared times y squared, that's just going to be 7y to the 4th. And that is our answer for D. Now let's take a look at problem E, where we're going to do some multiplication. We've got 9x squared times y to the 3rd. We're going to multiply that whole thing by negative 2x to the 3rd, y to the 4th. Okay. When we are multiplying single terms, it's all multiplication here. Even though you see that negative sign, that means negative, not subtract. It's all multiplication here, and multiplication is commutative and associative. So we can actually multiply our 9 times our negative 2 and get negative 18. We can multiply our x squared times our x to the 3rd and get an x to the 5th. And we can multiply our y to the 3 times our y to the 4 and get a y to a 7. Okay. Make sure you understand why we are adding the exponents here to get this 5, we added the exponents, and to get this 7, we added these exponents, okay? Because we're adding up the number of times that we're going to multiply by that base. All right. So for this guy, our simplified answer is negative 18, x to the 5, y to the 7. All right, take a minute, make sure you fully understand how this works, okay? Now we'll go on to talk about scientific notation, because we also use exponents just a little bit in scientific notation. Basically, scientific notation asks us to write all of our numbers as just a single digit in the ones place, so a single digit to the left of the decimal, and all our other digits will be to the right of the decimal. And we're going to write our numbers like this by multiplying the number by some power of 10, so that we still have the same magnitude that we started out with. It just all looks like one or a number point something something. Okay. So our first example, we've got this huge number. Let's see, I can't even tell if that's a billions, but it's 1, 3, 5, 6, and then we've got 3, 6, 9. I think we have 10 zeros there. Okay. So if we want to write this in scientific notation, which we definitely do, because you can see this is really hard to even just tell how big this number is. I mean, just counting those zeros is pretty hard. So to write it in scientific notation, we basically move the decimal from where it is right here, and we move it over to just after the first digit. So to do that, we're going to have to move it over 3, 6, 9, 10, 11, 12, 13 times. So we're essentially dividing by 10, 13 times to get this new number. So to make it the original number, we're going to multiply it by 10, 13 times. All right, so this is scientific notation of our number. And now we can actually see how big our number is. It's got 13 places past the first digit, okay? So this is a very big number. Now we're gonna look at this smaller number. The decimal is way over here. And again, it's really hard to tell even what place value this 5 is in, okay? So we're gonna wanna move the decimal all the way to just one past the 5, just past the 5. So we have to figure out how many times we need to move the decimal: 3, 6, 9, 12, 15, 16. We're going to move the decimal 16 times to the right. So we're essentially multiplying this number by 10, 16 times. So we're going to have to divide it by 10, 16 times to get back to this original number. Okay. So these numbers in scientific notation are equivalent to the number in non-scientific notation, right? The negative 16 tells us is that this number is really, really tiny. It's 16 places to the right of the decimal. This positive 13 tells us that this number is really big. It's 13 places to the left of the decimal. When we multiply out things that are in scientific notation or divide through things that are in scientific notation, it's nice to use the distributive property to regroup our numbers. All right, so here we have 43 times 3 times 10 to the 2 divided by 1.5 times 10 to the negative third times 8.6 times 10 to the negative 14. So we can regroup our powers of 10 and our regular numbers, and that will help us to just find out that these regular numbers multiplied and divided actually just come out to 1, and then we have our powers of 10. So this is going to be 10 to the 20th. Okay. Now let's take a look at the last thing we want to cover in this section, which is working with some geometric formulas. Really, you might be asked some kind of complex questions to find either surface area or volume of some weird shapes. But what you want to do anytime you're problem solving is use the formulas that you know and break the problem up into smaller pieces. So we're going to find formulas to calculate all of these different things: the surface area of a box, the surface area of a soup can, the volume of a bird bath in the shape of half a sphere, the volume of a gold bar that is a right trapezoidal cylinder. So first of all, let's take this box with 6 sides that are, and it's a rectangular box, so it's got a length, a width, and a height. And if we want to find its surface area, we just need to add up the area of each of the sides. Each of the 4 sides around are going to be length times. Let's see, we've got front and a back, that's going to be length times height. A left and a right, going to be width times height. And a top and a bottom, that's going to be length times width. Okay, so we're going to have to add up the top and the bottom, the back and the front, and the left and the right, all 6 sides, to calculate this. Now let's say we want to find the surface area of this soup can. We are going to have to break it apart into a couple pieces. First, we're going to take the top and the bottom off. Those are circles. We can find the area of those circles, pi r squared. And then we have the vertical sides. Well, when we unwrap that, that's actually just a rectangle with a height of h, and the width of this rectangle is going to be the circumference of the circle. The width of the rectangle is the circumference of this circle down here. And we know the circumference of our circle is going to be 2 pi r. So we can calculate the top and bottom areas, pi r squared, and the area of that rectangle is going to be the circumference of the bottom, pi r squared, 2 pi r times the height. Right. Now let's find the volume of this guy. We know that the volume of a sphere is 4/3 pi r squared. And if we want to find the volume of this thing, well, we've really just got half of a sphere. So we've got 1/2 times 4/3 pi r cubed. Excuse me, I meant to say cubed earlier. And we can simplify that fraction. So our volume is going to be 2/3 pi r to the third. Oops. All right. And you can plug in that r is 4/3 to calculate this volume. Then finally, let's say we have a right cylinder that is this object right here that you see. Sometimes we call it a prism. If we want to calculate the volume of this, it's going to be the product of the area of the plane region and the distance that the region has been extended perpendicular to itself. Okay, so we're going to basically figure out what the area of the base is and then multiply that by the length or how much we've stretched this. Find the area of this base here and then multiply that by the stretch. Okay. So the area of just that trapezoid base is going to be 1/2 the average of these two sides, the top and the bottom, times the height of that piece. And then we just have to multiply that by how far we've stretched that base. So our volume is going to be this formula right down here. And that concludes section 1.4. Go ahead and take a look at these slides in the slide deck, or come back to any section of the video you need. All right, have a good one.